In this lecture, we're going to examine a concept called statistical power through an example and examine some of the factors that can affect statistical power. Statistical power is defined as the probability that a statistical test, a set of equations, will result in an answer that will lead to the rejection of the null hypothesis, and is basically the probability of attaining statistical significance. And recall that a statement of the null hypothesis is a statement that two or more groups are not different. And if we reject that null hypothesis as a result of the statistical testing, we are stating that the two or more groups are significantly different. The symbol for statistical power is 1 subtract beta, which is the symbol for type 2 error. And in this example, we're going to examine a new drug that is designed to reduce blood cholesterol levels. And the first group involves patients who have high blood cholesterol, and these patients are prescribed a generic drug. And the measurement of blood cholesterol was made prior to the prescription of the drug. So a pre-treatment measure of 250 on average for the participants and for the patients in group 1 was obtained, and a post-treatment average of all the patients after a period of drug use is 240 milligrams per deciliter of blood. The participants in group 2 also include patients with high blood cholesterol, but these patients were prescribed a new drug. And the results here indicate that prior to using the new drug, the blood cholesterol level changed from 245 to a post-drug usage or post-treatment value of 230. So the overall question here is whether the new drug was more effective than a generic drug at reducing blood cholesterol levels. And so we then further examine these data, and with the first group, we take the difference between the pre-treatment, or also referred to as the pre-test value for blood cholesterol, and we subtract the post-test value, and we have a 10 milligram per deciliter decrease in blood cholesterol. The participants in group 2, we carry out the same calculation, and we found on average there was a 15 milligram per deciliter decrease. Now, by examining the average decrease from pre-test to post-test for the first group, pre-test to post-test for the second group, we see that the second group, just by examining the average decrease, we might conclude that the new drug was more effective. However, in this analysis, just by observing the average values here, we also need to consider the variability in the responses within group 1 and within group 2 of all those patients. And statistical testing will incorporate the variability of the participants in each group separately when carrying out this analysis, because it does play a very important role. As a result, if a statistical test is carried out and the statistical test using the calculations indicate that we accept the null hypothesis, we would state that the new drug is not more effective than the generic drug, and therefore we would have to accept the null hypothesis. And what we see here is that despite the fact that the new drug group experienced a 5 milligram decrease more than the generic drug group, the statistical equations would suggest to us that despite this value, they are not significantly different. Now, with this statement, we are running the risk of committing a type 1 error. The actual decision here is to accept the null hypothesis, when in fact it should have been rejected. If we have that scenario, we have committed a type 2 error. And the level of risk is much lower for a type 2 error than it is a type 1 error. And so in this statement here, if we commit a type 1 or type 2 error, the drug is actually more effective than the generic drug. And so statistical power relates to the ability of stating that there is a significant difference between two or more groups when a difference actually does truthfully exist. But there are factors that do affect statistical power. The first factor is the alpha level. And so by selecting a 5% or a 1% risk of committing a type 1 error, moving from 5 to 1 will increase statistical power. And so using a one-tailed or two-tailed approach will also increase statistical power, and this is an approach that we will address in later units. In terms of sample size, a larger sample size will create a tighter distribution. In other words, the data, due to the large sample size, will be located closer to the average. That will actually decrease the risk of committing a type 2 error and will increase statistical power, so that if there is a true difference between two groups, the statistical test will detect it. A smaller sample size will see a wider distribution in the scores contained within each group in a research study. As a result, the risk of committing a type 2 error, which is beta, will actually decrease statistical power. And to recall, the variability, or the standard error of the mean, is going to be inversely related to the sample size. So as the sample size gets larger and larger in this denominator, the error will get smaller, and with the smaller error, we have a better ability to detect a difference between two groups if a difference truly exists. In terms of the variability, this is linked to factor number 2. A larger sigma, or a larger population standard deviation, will produce a wider distribution of scores. That will decrease the ability to detect a difference between two or more groups if it actually exists. So a smaller standard deviation, which is related to a larger sample size, will create a tighter distribution of scores and will therefore increase statistical power. The fourth factor is related to the actual differences between two or more groups. And so in this example here, we're examining one group versus a second group that we just simply label as 1 and 0. And so the greater the actual difference in the means, the larger the power, the greater the chances that the statistical testing will be able to conclude that there is in fact a difference between the two groups. And so the magnitude of that difference is going to be a function of the treatment effect that is generally referred to as the effect size. So the term effect size is a statistical term that relates to the magnitude of differences between two or more groups. The lower the difference in the means would lower the statistical power and reduce the ability of detecting a significant difference if it truly did exist. So this ends this lecture on statistical power.